Welcome to AM 301, Implementing MLOps Practices with Amazon SageMaker. ML has been impacting companies in all different industries, letting them make major breakthroughs with use cases like predictive maintenance, recommendation engines, demand forecasting, and even anomaly detection with computer vision. And with that all said, companies are still trying to figure out how to speed up that process and do so without sacrificing quality. While companies are really generally good at CI/CD for applications, doing so for ML hasn't been quite as easy at scale. So companies are looking for answers to fundamental questions like what version of the model is in production? What data was used to build that model? And my data scientist expert is moving on to the next big project. How am I going to rebuild these models? So, and as the data scientists that are out there listening today, you're looking to move quickly, to iterate fast on building new models, doing hundreds of experiments, and you don't want to be certified in MLOps or infrastructure. The ML engineers watching, you're wanting to really help those data scientists move quickly, but you're on the hook for operational excellence and being able to make sure that models can be rebuilt easily. So my name is Mark Roy. I'm an AI/ML solutions architect at AWS, and in the next half hour, we're going to answer those questions. We're going to help you figure out how to operate ML at speed, at scale, without sacrificing quality. Let's take a look at the agenda for today's talk. So first, we'll go into understanding Amazon SageMaker ML workflows overall, and then we'll dive deep into how to automate those workflows using Amazon SageMaker Pipelines. And lastly, I'll take you through about a 10-minute demo end-to-end, showing you how to start with a brand new project and go through data preparation, training, and deployment across multiple environments with approval workflows and more. So to set some context up front, I'm not going to cover the basics of SageMaker, but let me just make sure that everyone understands SageMaker provides an end-to-end machine learning platform that goes all the way from labeling your data, data preparation and collection through using Jupyter notebooks to build and design new models, through all of the training and tuning across hundreds of iterations of your model with different algorithms and hyperparameters and experiments, and finally, all the way through to deploying those models in multiple environments, managing them, monitoring them for data drift and model quality and so forth. And while this is all an end-to-end complete environment, you get to choose which pieces of it you use. So you don't have to use everything. You can pick and choose the pieces that are most important to you. And today we're going to focus on overall SageMaker pipelines to help you automate the end-to-end process. Now, when we talk about MLOps practices, I recognize that people and process are key to success with MLOps. Today's focus will just be on the technology part, in particular, automating ML workflows and CI/CD pipelines themselves. What we find is that a lot of companies start with some basic automation of ML workflows, and then they move on to incorporating CI/CD practices, such as source code and version control, automated quality gates, and so forth. And although this is a very high-level diagram, I've personally had a number of customers come to me and say, well, tell me what the best way to do this is. And the answer is that there isn't a best way. So there is no golden pipeline out there for you to, for me to give to you to answer your MLOps challenges. What's important is for you to go deep in understanding what are the different types of models that you're building, what technologies are you using, what skill sets do you have available, how are you doing automation already for traditional applications, and so forth. You need to think all of these things through, and the technology should be the easy part from there. So before we go into SageMaker Pipelines, let's set some foundation about how are models trained and built using SageMaker. And let me take you through 3 different ways that customers use SageMaker to do that today. The first way is using built-in algorithms. We provide 17 different algorithms for you to choose from. And you can see the training image and the inference image are grayed out there, and that's because SageMaker gives them to you. What you need to provide is what are the hyperparameters that you want to use, and then provide the training and training, testing, and validation data that will be used. Out comes the model artifacts from that training, and that can then be deployed into different environments. So that's the first approach and the most straightforward. The second approach, and maybe even more common, is when you want to use a built-in framework. So instead of an algorithm that's got everything figured out for you, you've got some really interesting algorithm that you want to bring forward in, let's say, TensorFlow or PyTorch or MXNet, maybe even scikit-learn, but you don't want to have to worry about all of the details of building containers and optimizing those frameworks. So you use our built-in frameworks, and you provide training code and inference code as a Python script. So that's the only additional piece involved here, but you get much more flexibility to customize to fit your needs. The third and final approach is when you need even more customization, and this lets you bring your own container. So bring your own algorithm or container. You get to build a custom Docker image with exactly the environments and the frameworks that you need, particular Python packages, let's say additional data, whatever it is that you need. So in order to do that, what you have to add to your training and deployment steps is producing those Docker images. So you provide a Docker file, additional code and libraries, all of the steps needed to do that part of the build. So those are the 3 different approaches. It's important to know that all of the inputs, the outputs, and the artifacts that get produced so that you understand how the automation needs to take advantage of this. So let's look at the challenges that are involved now that you understand this context. So if you're responsible for building and scaling out the end-to-end workflows of such an environment, the first step is figuring out how to build those ML workflows. That can be a challenge on its own because it involves stitching together many different technologies, managing dependencies, and so forth. This takes quite a while to kind of figure out and get captured effectively. And as you're trying to iterate on making that exactly how you need some troubleshooting. And you need to figure out how to keep track of all the different dependencies and the artifacts. And companies typically end up having an army of ML engineers to help this out, to help out the data scientists get this done effectively. Even larger challenge is managing models. So, hey, if you've just got 1 or 2 models or even a half dozen, probably not too big of a deal to keep track of all those. But when you start getting dozens, hundreds, and a lot of companies are into thousands of models now, how do you manage all of those? How do you know which ones you've got, what versions you're at, how those were built, and what environments they are, and so forth? This is a big challenge for most companies. Trying to automate and scale further is another huge challenge because you have multiple different data science teams across different organizations. How do you actually offer ways to add some consistency to those development efforts for new models without duplicating code and getting teams off the ground quickly while keeping track of all the different artifacts, the code, the data, and results of training along the way. The last big challenge is tracking lineage. A lot of the companies that I work with are regulated in some way, and they have to provide a way to get from this model to how is that built? What is the lineage? Where did the data come from? What were the hyperparameters used? What were all the steps along the way that produced this model? So they can provide that to various stakeholders to understand what's behind a given model. So with all of those challenges in mind across all of the companies out there doing ML, we came out with SageMaker Pipelines late last year. This is a purpose-built CI/CD service for automating, building, managing, and scaling ML workflows. Let's take a look at how Pipelines addresses these challenges that we just went through. From the perspective of building workflows, there's a Python SDK for easily defining your steps and dependencies, inputs and outputs. For troubleshooting, we let you visually see the pipelines that you've defined graphically and monitor their execution in real time and drill into them, stop them, rerun them, and so forth interactively in SageMaker Studio. For managing models, we introduced a model registry. This works across teams, across projects. You can register all of your models and automatically keep track of versions and metadata for your entire environment. For automating and scaling, we've got multiple built-in project templates provided that give you point-and-click deployment of an entire end-to-end CI/CD infrastructure for data scientists. And you can customize those as well, and we'll describe that a little bit more going forward. And lastly, with respect to Lineage, SageMaker Pipelines keeps track of all of that throughout an entire complicated pipeline across steps and dependencies. You can see where all of the data came from, what parameters and settings were used. You can easily reproduce that and do that at scale for thousands of models. This gives you collaboration between data scientists across teams with ML engineers, MLOps and DevOps folks, and accelerating your projects without taking a hit on quality of those models. Next, let's talk about the three main components that are provided in SageMaker Pipelines. One is a project. So in Studio, you can create a brand new project based on a template that SageMaker provides, or you can customize those templates or provide your own. That will get you access to source code repositories and have built-in triggers for rerunning pipelines, which brings us to the second component, and that is the pipeline itself. This is where we're dealing with automated model build workflows for training models across steps with conditional steps as well, and the ability to have multiple executions of those all fully managed on your behalf. The third major component is that model registry, which works across multiple projects and pipelines, letting you have a central place to store and manage models and model versions. And this service gives you that end-to-end traceability and the full automation that's needed to speed up your ML projects at scale. Okay, drilling one level deeper on each of the core challenges that we're trying to address for your teams. For building ML workflows, the SDK lets you define in detail, but very easily for a data scientist in Python. You can simply just define a new step, set the parameters for that, set the entire flow, so you've got the movement between steps and dependencies, and then you can easily save those as an entire workflow or pipeline. From there, SageMaker will automatically orchestrate all of the different jobs that are involved in a full end-to-end pipeline. So that can be general purpose processing jobs, that can be training jobs that are distributed across multiple machines, batch scoring. You can even incorporate our new SageMaker Data Wrangler data transformation steps that you've built through SageMaker Studio. And of course, automatic model registration along the way. The last piece in terms of building is triggering executions. So a key here is, as we're talking about MLOps practices, is model retraining strategies. So if you've got a certain amount of model drift based on model monitoring, you could automatically trigger execution of the entire build pipeline, or based on the arrival of new data, for example. This is in addition to manually being able to run a pipeline whenever you'd like. In terms of troubleshooting, you can visualize graphically the entire pipeline, even complicated ones, zoom and pan around that entire pipeline. And as it's executing, you can see the status in real time, drill into any of those steps to see how it did, go into the detailed logs in CloudWatch, see the inputs and the detailed outputs, where the artifacts landed, and so forth. So all of that's available in real time as pipelines are executing. And you see the full history of executions as well. For troubleshooting purposes, you can also stop a pipeline if you see something going wrong. You could do some debugging and diagnosis, and then rerun the pipeline. You can even cache some of the earlier steps to avoid expensive and time-consuming pieces that have already been completed. Okay, here's a quick visual. We'll go into a lot more of this in the demo, but you can see in the center a visualization of a very simple pipeline. On the right, you can see a drill down panel where we've selected one of the steps of the workflow, and you can see various settings, metrics, and even logs. Okay, moving on to managing models. Again, the SageMaker model registry gives you that complete catalog for managing hundreds or thousands of models across your company. For each model, you can manage any number of different versions of that, understand where each version is in a particular environment, get at all of the metadata associated with that model, as well as look at evaluation metrics. There's approval workflows built in, so you can either automate that in your pipeline, or you can have a manual step where someone can use SageMaker Studio to see, oh, I've got a model version that's waiting and staging. Let me right-click and approve that and continue the pipeline. And lastly, we know that most large-scale AWS customers operate across many different AWS accounts. So what Pipelines does is let you securely access model artifacts across different accounts. Let's say you're moving from development to testing or testing to staging without having to copy artifacts and without having to rerun entire pipelines if you don't want to do so. So that's all built in as far as cross-account support goes. Here is a picture of 6 different versions of one model in the registry with a dialog for doing a manual approval step. And you'll see this in the demo very shortly. For automation and scaling to many different models, a huge time saver here and an ability to make things consistent is this notion of built-in and custom MLOps templates. So these templates are used with MLOps projects in SageMaker, and so you can define how all of your CI/CD will take place, multiple stages, multiple environments. You can define the set of source code repositories that ought to be used for a given project, provide the right structure, and even provide starter template code in there that a data scientist could simply extend the training script or the pre-processing script to meet their needs for a new model. All of that is built in, easy to take advantage of the available templates, customize them, or add your entirely new templates. You register these with the service catalog, AWS Service Catalog, and from there, they're easily available in Studio for a data scientist to create a new project and get moving. Lastly, the CI/CD capabilities integrate with the native AWS services like Code Build and Code Pipeline. The last challenge that gets addressed with pipelines, I'll hit really quickly, and that is lineage. So when you define and execute SageMaker Pipelines, you automatically get end-to-end lineage tracking so that you know where the data came from, all of the hyperparameters that were used for training, any inputs that were used for the data pre-processing, the model evaluation steps and metrics, where the model artifacts went to, and so forth. So when you need to understand where did the model come from, you've got all of that data available either visually through SageMaker Studio, or if you want to build your own custom reports and do some queries, you could use the Python SDK to get at that, even including custom entities that the SDK supports for you to do that. Okay, it's time for the demo. So let's take a look at an end-to-end workflow using SageMaker Pipelines.
I'll start the demo by creating a brand new project. First, I navigate to the Projects tab, Create Project. I'll pick a built-in template. This one is for building, training, and deployment of new models. So I'll select that template. All I need to add is a project name, so I'll call it New Project. Click Create Project, and I'm good to go. Studio will do the rest. This takes about 2 minutes, so I'll pause here and come back when it's done. Okay, and we are back. The project has been created. And for all the data scientists watching this demo, the combination of SageMaker projects and pipelines is pretty powerful. Pick a template, enter a project name, and you get structured code repos and an automated pipeline to handle feature processing, model training, and deployment without having to be an infrastructure expert. And the ML engineers watching should be excited too. Instead of having training scripts tossed over the wall, you now get to prescribe best practices for organizing and securing repos and enforce standards on how ML pipelines are wired together, making it easier to maintain them over time. So data scientists can collaborate more easily and, most importantly, get new models to production more quickly. So the full pipeline takes about 10 minutes to run through. So while that's running, let's take a look at a project I built earlier so we can dive into more details about how it all works. So I'll bring up another project called Demo New. So notice the project window gives me easy access to the project code, the pipelines, models, endpoints, settings, and more. Let's look at the pipeline for this particular project. So you can drill down into the execution history. You can see a graphical view of the pipeline steps, and you can look at the input parameters and other settings. This particular pipeline has pre-processing, training, model evaluation, and a conditional registration of the model. If the model doesn't perform well enough, we don't bother registering it. So you can trigger pipeline executions based on code updates or new data, or even launch the pipeline directly from Studio with this button to start an execution. So let's dive into one of the executions of the pipeline. So you can see any of the steps that are in green here are successfully completed. You can click on any of these steps to see the details of each step. So here we click on the pre-processing step. You can see some output. You can get to logs and CloudWatch and so forth. Here we can click on the conditional check on the metrics. We can see that that evaluation outcome was true, which led to registration of the model. So we navigate back to the project window and we can click on model groups. This is the model that is being built by this pipeline. And here, this is the model registry for that model. So you can see the full version history. And for each version, you can see all the activity. So here, version 1 was rejected. It wasn't good enough. Version 2 is in staging and waiting for approval from DevOps before it goes to production. And we can see version 3 is still pending approval. So all I need to do is check out the execution metrics. So let's go back and see how that went. So we go back to the execution history. I'm going to look at the training output. It looks like the RMSE was 2.3 on the validation set, so I'm pretty happy with that. So I'm going to approve it. So we can just click on version 3, update the version status to approved. You can add some comments if you'd like. Here I'm just going to go ahead and approve that model. So what ends up happening then is that this is now able to get deployed to staging and run through an automated test suite. And we can look at the details of a specific model version as well. So we can double click on version 2, let's say. And while we're looking at those details, notice how you can see it was initially pending approval. The status got set to approved. We see who did that, what user, and then you can see that it's got deployed to staging. The current status is approved. You can easily access the pipeline itself and the actual execution details that led to creating version 2 of this model. So not only can you now reproduce the models reliably, but you have a complete tracing of all the artifacts and the steps along the way. So no more mysteries about how this model was created. And let's say a data scientist moves on to some other project. There's no scrambling to find a way to rebuild the model. It's all captured. Now let's pretend we are on the DevOps team and we get notified there is a model ready for release into production. When this project was created from the shared template, the CI/CD pipelines were set up behind the scenes. So let's go to the code pipelines in the SageMaker console. And we can see that this model was built. It was deployed to staging. A test suite was executed. Now it's waiting for me to either approve or reject it. I'm going to take a quick look at the details of the testing. I can look at the logs here, and it looks like the testing was successful. Success is true here. So I'm going to go ahead and approve this. I could add comments as well, but I'm just going to approve. And now the prod deployment automatically starts and my approval is recorded. Okay, coming back to the data scientist role, let's see what happens when you change some code. Let's say I want to adjust the train test split and give more data to training. Let's hop back to the new project that I created. See how that one is doing. Looks like that is just about finished. It's probably got another 30 seconds to go. But what I'm going to do is go to the actual code for that. I'm going to clone the repo locally for model building. That will let me access the code to make my quick change, and then I can commit the change to code commit. So I'll just go to pipelines, find my pre-processing script here. I can navigate there. I'm just going to search for split. Let's keep going. Right, and here's where I do the train test split. I'm going to go from 70% up to 75%. and rerun the model. So all I need to do is save this. I can go back to the Git tab in Studio. I can see that it knows that I made that change. I'm going to stage that change. Now it's here. I'm going to commit the change and say change train test split to 75%. I could add comments, of course. I'll commit that change, put in my name, and click OK. That's been committed, and now I'll just do a git push on that, and we are good to go. That will automatically trigger a new run of the model build pipeline, and I'll get to track that in Studio and see that executing and so forth. It's all fully automated and triggered just by simple code changes when you commit them to code commit. So within a minute or two, the new pipeline execution is started, and a brand new version of the model will be built and automatically tested. All of the changes and the new artifacts are fully tracked. So that brings us to the end of our SageMaker Pipelines tour. You've seen a project created from a built-in template and automated pipelines covering pre-processing, training, and model deployment. I've shown you model approvals, pipeline execution triggered from code commits, and full tracking of all the settings and artifacts across the entire pipeline. The demo used a built-in template, but remember, you are free to customize your own project template to use across different teams to match how you'd like those teams to operate going forward.
Welcome back from the demo. So we took you through an end-to-end SageMaker pipeline and showed you how to create new projects, automate CI/CD, as well as manually do approvals, look at the model registry, and a pretty powerful way to speed up your ML projects without sacrificing quality. On the next slide, I'm showing you some resources that can help you go deeper on MLOps practices with SageMaker. First, some foundational knowledge, the well-architected framework for ML, as well as some white papers. We've got some hands-on workshops that you can go through, as well as a pair of blog posts that are very good, covering how SageMaker Pipelines works, including going with multi-account model deployment. We also want to encourage you to continue your ML journey with AWS training and certification. We've got a lot of courses available online for you to dive into based on your role and your interests. We've got a number of free courses as well. You can even get certified with the machine learning specialty certification. And lastly, there's a number of labs, white papers, and tech talks available in the ramp-up guide. Okay, so thank you for listening to this session on MLOps practices with Amazon SageMaker. My name is Mark Roy, and I wish you the best of luck on your ML journey. Please do complete the survey so we can get feedback on what you like and where we should improve. Thank you.